in Postgres, and I'm not sure about other databases, you have the ability to perform recursive queries using something called a common table expression. They look something like this here, and I'm going to show a few more demos. And they're pretty cool because basically what you're doing is you're defining a view with that name, which you then give an initial value, and then you're doing a union of future values, which you pass in the previous value as a term for that view. So you're basically appending on to this virtual view recursively in the query, and then you can do whatever you want with it in a higher level outer query. So that lets you do crazy stuff. I'm sure you've all seen, maybe not, there's been a few things like someone decided that, hopefully my internet works. There we go. So someone decided that it would be really cool if you did the Mandelbrot set in SQL. Because, basically because they could. So what we're doing here is you're generating, you have your substring array, which is also, I don't know, does MySQL have arrays in them? Can you like have a column with an array in it? No. Okay. So Postgres you can. You can have a column, you have an array data type where a single column can hold an array of data items. So it's like a column in a column. It's weird. Anyway, you have your substring column, and then you're defining your points over the fractal set and mapping each one of these substrings to a point on the fractal set, and you get something like this. That is it's a little big. There we go. Maybe y'all can see that. And then you get the Mandelbrot set. Hooray.
It reminds me though of
to run?
things.
Yeah.
I'll run it right here.
Oh, okay.
I'm going to run that. I wasn't planning to run that one, but I do have other ones. These are actually fairly efficient, which is hard to wrap your head around, but they are.
You could just tell me how long it took.
I don't know. I've never actually run it.
Oh, okay.
So unfortunately, I have not figured out how to make my font size bigger here. It seems to be broken. No, that wasn't it. Oh, there we go. That's something.
It's a man with bacon.
There we go. Huge. Is that better?
Yeah.
All right, now let me just fix the color. There we go. Can you all see that? Is that somewhat okay?
Probably better if we turn off the lights.
I got the door, turn off the lights.
Oh yeah. Or there's a dimmer switch, maybe that's the one. Nope. Okay. There we go. Cool. So this first one is really simple. Let me so you can see the actual output too. Would be nice. So the first one's pretty simple. All I'm doing is I'm starting with an array of 1, and I'm counting up to 100 in that array. So you have I'm defining my recursive view or table there. It's a temporary table, by the way. They're not actually materialized ever. They're all in memory. And then I say start with this value in an array, and the append operator. This is like if you're used to a functional language, like a cons operation, and then cons is on, and I'm just limiting it here, and what I'm doing here is I'm saying don't give me any of the other arrays, because what it would actually be, because it's unioning, it's actually appending on every other array from 1 to 100. So you get crazy, you get a lot of output, and it's not so useful. But hold on a second, I ran the wrong one. Fish out of water here. There we go. So if you see on the bottom here, I've generated the number sequence from 1 to whatever, 100. So you can also do other things like here we have a prime number sieve, the sieve of Eratosthenes, and we found that in SQL it's not all that fast. So up to 1,000. So you all know what the sieve of Eratosthenes, how it works. Like you have the numbers and then you strike out everything from 2 and that's divisible by 2, and then you go up to the next number, and everything by 3, then you go up to the next number that's still there, and you construct all the prime numbers up to whatever. So we found that once you got over 1,000, like started hitting numbers like 10,000, 100,000, SQL is just not able, the engine is just not able to process fast enough. It's definitely not ideal for large numbers, but up to 1,000 it's really fast. So let's see, R, and there you go. So on this guy, you can see we've got all the primes from 2 to 1,000. It's kind of fun. And the cool thing is that you could if you had an application where for some reason you needed this in your database, you could define it as a PL function and just run it on the server. You don't have to have it over a client. So let's see what else we have here. This is just this. I started doing Euler problems in SQL for a little while. I'm not sure if you all are familiar with the Euler project. It's 260 really hard math problems or computation problems. So this is one of them. It's the sum of all numbers that are divisible by 3 or 5 below 1,000. So we can easily calculate that. And there you go. It's 233,168. So
what was that computation again?
it's the sum of all it's the sum of all numbers that are divisible by 3 or 5. So you don't want to count a number like 15, you only count once, for instance. And that's where you use this, you can use case statements to sort of select one or the other, and then you also have to have an incrementer. And other problems that are in the SQL domain can actually be made really easy. Like if you want, this is how many Sundays were there in the 21st century? Which is in other languages actually really hard because you don't have the date library that we have. Like Postgres, MySQL, we all have really good timestamp parsing and timestamp operations. Other programming languages don't necessarily have that, so something like this is actually trivial. 171. You know, you could do that. You could say how many Sundays and Mondays where they landed on this day of the week or things like that. You could really be very expressive with that type of stuff. Let's see what else. So I have a Fibonacci sequence generator. That's always fun, but it's pretty easy to do in this stuff. I can go through the actual, this is a function where A is actually nothing and B is the number, like A is, so that these are your seed values, 0 and 1, and then you're using A and B to keep generating because you need the last 2 numbers in the sequence in order to generate the next one. So, you know, take your greatest, add it, and there you go. And so where the $1 is just my limiter from the function, so I can generate Fibonacci numbers up to whatever that limiter I say is, so I'll run that. So that created my function, and I can do select fib, like 1,000, 100, sorry. And there's 1 through 100. I can do select fib 100,000. Let's see how long that takes to run.
Okay.
There we go. So it's pretty quick.
Yeah.
As it hopefully should be. All right, and then
It's really scary when you put into real world things.
yeah, and I mean, these are. I think this syntax is pretty new. It's been in the standard for a while, although like the option to have recursive queries has been around, so you can. It definitely makes SQL much more expressive. So you can, I mean, there are a lot of problems which now fall under SQL's domain as well because of this.
Yeah, I would never have thought of doing it in SQL.
And here's the Mandelbrot set, just for fun. There we go. That's how long it took to run. So it's pretty quick. And this is on a laptop too, not even, it's a default install of Postgres. No optimization. I think I have 4 gigs of memory, a really slow disk. So
Are your queries posted somewhere? Are
these are, a lot of these are on the Postgres wiki. That's like, if you go to the Postgres wiki, oh, it's up here too. Right. There's something called fun snippets. And there's also, you can do, someone did pie charts, which is cool. So given a data set, you can, it's pretty small. There we go. So given, you set up what you're going to use to define your pie chart, using what strings you're going to use for your pie chart, and you say how big I want it to be, and there's my laptop. And then you're actually creating the radius with the string values. Then you're turning that string array into an actual substring and grouping it all together, and you get stuff like this. So I think these queries exist more to show that you can do it, not that you should. I'd like that, just to say that. Like, I don't recommend doing this as a, like, this is not going to make your application faster. Doing pie charts in Postgres is not probably the best use of the application. There are easier ways to make pie charts, but it sure is fun.
Good Easter eggs.
Yeah.
Yeah.
You have your homework problems yet, right?
Which homework problem?
Your 260 homework problems.
I think right now I'm almost at 25. They're hard, but I've been doing most of them in Haskell because it's a lot better. There is a Sudoku. I hadn't seen this. This is new. So this is a Sudoku problem solver. I've actually never tried it, but I'd be interested in people wanted to hack on these or had other ideas for fun little queries. Yeah, we could do an afternoon, whatever problems you have.
Anything that involves cheating at games.
Yes.
Yeah.
Especially cheating. So there are a lot of other. I guess someone cleaned this page up. Nice. So there's a lot of other queries which are around. Like if you want to, there are all sorts of administrative queries you can run. Performance. Let's see, where did they hide the other stuff? So does anybody else have like experiences with SQL where they've done something they shouldn't have, or I don't want to just talk at you, but I'd love to hear about it because I think it's pretty interesting. Like people do array aggregates. So this will, if you have an array, aggregate that together. Let's see, what else do we have in this category? I don't know. That's a good question.
Yeah, press bar is really useful.
Doesn't look like it. Do you want to? Do you have one that you could show off?
I'll just do it if I can.
Okay. Yeah. So
I like using the case statement and the order clause. So if I'll do one query to get back a bunch of IDs in a sorted order that for another table, then I can just do find these IDs order by case. When it's this ID, then 1. When it's this ID, then 2. That way you can like force an ordering without having to like necessarily go to disk for a small set. It can work a little bit better than just getting an undetermined order back in the database.
here's a cool one. Postgres has a PL Perl where you can write Perl features in a procedural language. Here's someone is using an email CPAN library to parse email addresses for data verification, which is cool. There's a lot of stuff. I guess if everybody sort of gets the CTE syntax.
CTE.
Yeah, that was what this syntax is officially called.
It might help. I think, though, to explain CTEs, it's probably better to start with an example that's not recursive. So you see that recursive queries take advantage of the CTEs, but they're not the same thing.
Okay, sure, yeah.
Because like sometimes you
you
might
can
have
write
the same
a
subquery used more than once in a larger query, and that's an example where CTEs are handy, because then you're not re-executing that subquery every time it occurs.
Sure, yeah.
What's CTE stand for?
Common table expression.
Okay, thanks.
It's basically, I mean, it's pretty much like if you were to write a big query where you had to put a subquery in your select clause and then use that same subquery in your where clause.
Okay.
Rather than do that, you just basically define that query as a common table expression and then use the name for that in both places. So that way it only gets executed the one time instead of every time it needs to be. Perfect.
Thanks.
And so that's, then you can, they built off that to get recursive queries.
Right.
So you explicitly declare it as recursive, and then it references
Yeah, you don't.
itself.
Well,
none
in
of
this case it's not recursive. It's just
none of these have to be recursive. Should make that clear. Like you can have a just.
But in order to call back into itself, it needs to be declared as recursive. Like if it references itself, it needs to be declared as recursive.
You can say values 1, and that's your. That is your. That should work. Yeah. So there I'm just defining a table T with the value 1 in it, and then I just this is sort of like the replacement for your subquery, right? So you could also say select star from T where max, or I'm just trying to think about how you'd well, that's sort of too simple, but if you had like a more complex join query or something, do you have an example of one you could think of where it would be a really
No, I just remember
it's
asking for that feature a couple years ago because I was writing a query that I had to keep reusing a subquery in. And
right.
Like, this is really annoying because it's
because exactly like when Postgres plans these queries, it doesn't have to keep replanning it every time.
Yeah.
Like it plans. It plans. That's weird. It plans this section and uses this value. So forget that. In a non-recursive CT, it's going to plan the if statement and collapse that, and then actually start planning the outer query. So that's more advantageous. It allows the planner to sort of pre-optimize the inner query in the plan tree. When you start, as opposed to if you were just to select subselect, subselect, subselect. If you start, as you keep nesting subselects, it makes the planner have to work harder and harder to figure out what you're trying to say. So you keep adding plan notes to the tree. This allows you to do it in a shorter syntax, which has less points in the tree. Makes it slightly faster. So I do a lot of queries which require sort of. So another thing that I've done is in the past is if you ever have done partitioning on a database, has anybody sharded their data or done data warehousing stuff? So the problem with data warehousing is that you have a lot of data. You want to split it up so that your tables are not as big anymore, that you have less rows in them. Problem is that in Postgres, a lot of times you need to have a prepared statement or something. The prepared statement doesn't know how to deal with all those smaller indices, the partial indices, so you have to have a function that loops over all the tables and executes a subquery on them and take advantage of that. I don't actually have that code with me because it's technically owned.
Well, I remember one thing I did for a client while I did my business is a really simple and fast queuing system based around just a single table. And what you do is use Postgres as advisory locks.
Yeah.
And you take advantage of the way the planner will short circuit if you have an index with an order by limit.
Okay.
Because then it just starts walking the index, and as soon as it finds a row it can get a lock on, it returns. So you get multiple readers going, and you don't have to worry about conflicts.
Huh.
It does. I mean, it's not something that is really kind of built into the way SQL should work, but it's just the way the planner will say, okay, well, hey, if I'm got order by limit 1, and I can walk this index as soon as it finds a row. But if you don't have that index, it's going to actually, one query is going to lock every single row.
Right.
Turn 1, so you start getting locking. But I mean, it seems like every time I read any kind of tutorial on setting up a queue, it gets like way overly complex. And I had a client who was trying to figure out how to use the advisory locks, and I was like, oh look, this works.
Yeah.
And it's like really simple, really fast, and you don't need anything extra. You just need like a work queue table. Like one of the hard things with that is a lot of times just trying to have multiple readers getting locks on, pulling so that they don't get the same thing
Exactly.
or block each other, and that just works. It takes advantage of the built-in locking.
Cool. Yeah. Have you seen, one thing that there was a lot of talk about recently was notify and listen in Postgres.
What about it?
So there were sort of suggesting that those could be expanded into query queues.
Mm-hmm. Yeah, but I think.
That thread was kind of
that's-
controversial.
It's very controversial. But so
Right, and that's the kind of thing I'm talking about when people
Yeah.
start talking about queuing. You can use notify and listen, but then you have to deal with like.
It's non-determined.
It's
it's
you can't.
non-determined.
You have to. Then you still have to add like another layer on top of that to ensure that you don't have, since you've got
Well, they have
multiple
no way to
listeners
see,
from the same
sequential.
notify.
Yeah.
Does everybody know what notify and listen is? No.
you want to.
Yeah, so notify and listen, it's just a very simple notification system basically. So like if you say listen and then some keyword like, listen cupcake and then, or whatever. Yeah, so you say that and then your connection to Postgres will at that point be a possible receiver for anyone who says notify cupcake. And that's true of anybody who connects to the database. So when you send out that notify, there's no like security on it or anything like that. It's just that everyone connected to the database will get the notify, and then if you're listening, you'll get a special message from Postgres saying something happened. And so then what they were trying to do with that thread was make it so that the notify would deliver a payload of some kind.
Yeah, they were.
Once you start doing anything more than hey, there's something to do.
Right.
It's like for what I was just saying, like if you had like the queue table, you could use that as a real simple way to just say, hey, there's something here,
Right.
so that instead of having to have a poll loop, you just have all the workers waiting for that event notification. And even if one row goes in and all the workers get that notification to go and read, there's not going to be a conflict because one's going to get a return true when it tries to get the lock.
It's just very
And the rest are just going to get false and go back to waiting
Yeah.
on another notification.
Yeah, notify is just a very simple signaling, and so one system that uses it is Ricardo, or replication system, and so anytime there's a change event, you can set up a Ricardo so it'll send out a notify, so any of the replication listeners will know that they should initiate a certain type of a sync at that point and, start doing some replication. But again, there's no guarantee that the messages are actually going to the intended recipient.
Not transaction safe, are they?
Notify? I can't, no, I think it would be outside of transactions, because there's no, yeah.
Well, you're just saying to
It's
a
just a
client,
signal.
come check something out.
Yeah, you're not, I mean,
Yeah.
it doesn't touch any actual table data.
Any data,
Right.
It's just,
yeah.
it's just like a, kind of an add-on to the database system.
Yeah. There is potential.
Register a listen in a transaction, and the transaction gets rolled back, and so you're not listening.
Yeah, I don't think that.
You just go back in time and unlisten.
Yeah.
Time work.
Yeah. So one of the projects that I'm sort of wanting to work on is adding Haskell as a PL for Postgres.
Oh, sweet.
If anybody's interested in helping
Consume
me
all
out.
available memory.
Yes. There'll actually have to be like a special buffer size for it.
Sorry.
Yeah.
That's awesome though. That'd be really cool.
Yeah. Yes. Right up until that point. So I didn't really have too much else prepared for this. I don't know. So I did mention arrays before. And I was thinking about them, but I haven't been able to actually think of like strong use cases. So you could have like multi-dimensional arrays or single dimension arrays. And you know.
I use them to store Excel coordinates. Have you seen that?
Oh yeah.
Yeah. I have, it's only square objects, so it's always, 4 points, it's not a big deal.
Sure.
Put as many as you want in there, but, yeah, that's what I use it for. Sorry, carry on.
Okay. Well, that's one. Do you have to have those queries around or no?
Sorry.
But you can do all sorts of fun operations, like you can find out the dimensions of an array. You can update certain. You can update all of it. You can find out the length. It's fairly basic array operations. Their example is who got paid what, and you can actually query the sub each index of the array individually. So you can say where pay equals, where someone got paid or whatever.
Those can be n-dimensional. They're not just 2-dimensional. 1 or 2.
Right. These are. I don't know if there's a limit. Let's see if it says anything about that. Yeah, I mean they have 3x3 arrays here. They don't actually. I don't. Aside from like what you can possibly hold in memory and how much patience you have, there's probably no limit to how big your array could be. But I would obviously I think there's a tipping point where it should just be a table, and you should actually use the relational model. But it's fun.
Arrays are homogeneous. They have to be the same type.
Yes. Yes. They're not containers or dictionaries or anything like that. You can't. Although I'm sure there's a way where you could define some funky type that is sort of like equivalent to a void pointer and cast everything around, but you have to. I mean, I don't think that would be the.
Is there anything about indices against the array type columns?
What do you mean?
Like, can you create indices against
No.
them?
No. You create an array, you're pretty much on your own. as far as optimizations go.
So probably don't use it in a query in a conditions then.
Well, it depends on how, like I said, it depends on how big it is. Like if you have an array of 100 members or something in a column, you probably should have made that into a table. You know, there's design issues there, as I think so. I don't know, does anyone feel like there would be a good reason to do that?
Like the example is obviously so contrived anyway.
Yeah, unfortunately I don't really know what people are using these for real for at the moment, except for yeah.
Well, it doesn't impact the
They
slot
probably use it
count,
for an
right?
array
It
of
would just be
things.
if you wanted to search.
Right.
You should have broken it out.
If only we had some way of keeping lists of things in databases.
Yeah.
So
Concept.
where's I'm gonna put you on the spot too. Where's your elephant thing? It's not coming up.
Huh.
GOR.
Probably.
Yeah.
Maybe Google knows.
Shouldn't that just work? Well, anyway.
You link to Selena.
You can just go to slash the.
Oh yeah.
No, it's not showing up in the folder.
Now if I just search it.
Maybe they dropped me. There I am.
So you've been writing
The SQ elephant, yes.
this SQ elephant.
Mark, every time Mark and I do a talk together, he puts these little ASCII elephants in there as the commentary, and they always have these thought things, and I thought, oh, wouldn't it be silly if I wrote
A function.
a function to create these? I mean, because, you know, copy and paste. Sorry.
Sometimes you copy the elephant.
If you want to see like an example of what I was talking about the other day, using right the way PSQL uses
Yeah.
arrays to format like the results for expecting the catalog, like load PSQL with -cat e,
Okay.
type /df, and then look at the query that it
Okay.
uses to generate
Yeah,
the table.
I'll,
And that's like what I was talking. It'll use like generate series in the subquery that'll then use like array to string to go to the formatting.
So
No, just back
And
to
then-
you know. Oh, you.
Oh, it's not formatted right on yours.
Yeah, it's gonna get a little extra white space there.
oh, I cut and paste
Yeah.
from
It looks like he's missing his whole trunk.
uh-oh. There's a bug.
That's an elephant.
Yeah, that is not right. Anyway, I will fix that eventually.
Patch is welcome.
Yeah, I don't know what happened there. That's weird.
That is
Oh,
really
well.
weird. Yeah, it looks like
Thank you.
something funky happened with your formatting.
Probably just want to pull it down instead of copy and pasting it.
Thank you, XBuffer cut and paste. So what were? Oh, right. The let's see here. I did new window. All right. So just PSQL minus E.
Cappy.
Cappy, right?
Yeah.
Test. So-
/df. And scroll back up so you can see the query. Yeah, totally different from me.
We'll put it up on the class.
I don't know. Let's see. There's some craziness with the case statements.
Yeah.
Go back, scroll back up after the video. What version is that you're running?
8.5 dev.
Oh, okay. I'm just looking at older. Maybe they've changed it up.
Yeah, they recently tried to optimize some of these. I know. So maybe, maybe that's, maybe they removed that stuff in that. There was a thread about that.
Yeah, the argument data types, they've got a function they're using for it now. Whereas what I'm looking at here is this massive, like,
Do you want
case
to?
statement. Do you have an older version installed?
No, I don't. I pretty much only run dev. Do you have an adapters?
Yeah, what do you mean? What is it?
Whatever, VGA. Yeah, it's.
The important thing is that they have some context, so we should just update it to a individual layer. Let's just grab it now. That's fine. It's pretty good. I crashed it.
Ah, yeah. I see.
That.
So for every argument, it adds it onto the array.
Well, because you can take the results of a subquery, wrap
Right,
an array around it, instead of getting a setback, it'll give you the array.
Mm-hmm.
So what it's doing, like what it's doing in here, is it needs to get the data type. So it's selecting against the table, will pull the different data types out,
Right.
and then formatting it correctly.
Huh.
And doing that stuff. So I guess they probably, it looks like what they've really just done is probably taken that case statement
Mm-hmm.
and collapsed that into a function in the later versions.
Sure.
Yeah, it takes a minute to wrap your head around reading those.
There's a lot of cases in there.
But yeah, I mean, I use this stuff a lot. A little while back, I was doing a little project, Python. I wanted a way to test a lot of different like DDL and functions and stuff. And so, but it really took being able to create a catalog to get the right to find out, what was, what I needed to be able to generate. I want to be able to like generate tests too. So I need to be able to inspect the catalog to find out like what function arguments and everything there. It's pretty cool. But yeah, so that was just, you were asking for examples for when that
Yeah,
was useful.
definitely. That's.
So I mean, arrays aren't, I wouldn't say their primary usefulness is actual data storage. It's more like just being able to process data.
So you put it into an array in a process of your query and
Yeah.
manipulate it.
Well, I mean, there's, they have like, they've got the,
Yeah, there's being able to treat a set as an element.
they used to, like, it was an example for like one of the array aggregates to take like a, a regular set and make it into like a CSV comment separated string. Before they had that built in, this was more like the way you would do it.
Cool. So if you're interested in common table expressions, I guess I should show off the new patches. I don't actually have the patches applied, but there is a not coming back. Anyway, there's a so now the next step that they've taken with this whole common table expression stupidity is that you can inside your with clause, you can actually alt right to a table. So before you could now you say with t as whatever, insert into my table, and then use the returning clause. There's a returning clause in Postgres. Yeah, I can get my I can show you, but basically when you say an insert returning, like sorry, how do I turn this on? So if you said if you say like with t as value, whatever, and this, so in that, this is going to return whatever the value is. But you can also, with the new syntax, say insert into foo, whatever data you want, returning new dot star, I think is the syntax, and then do a select from the t. So as you're inserting, you first insert, then you return that set, like the new data that you just inserted, and select on it in your outer query. And this, I believe it's not recursive yet at the moment, but they're working on it, and they're trying to convince Tom Lane that it's a good idea. But it's kind of crazy because you can basically it's not necessarily faster because it's really boils down to the same relational algebra at the end of the day. It's just this allows you to simplify the syntax or make it less verbose. I don't know if it's simpler because this would be the same thing as saying, oh yeah, so here's a good example of where that would be the same thing as saying select star from foo, or from insert into returning foo, right? So you're sort of taking this block and making it into a with and flipping it up on the top and putting this at the bottom. So it's sort of visually looks more like how the order of the operations are actually going to take place. I don't know. It sort of makes a little more sense to me. But there are problems with having the insert inside inside the with statement because there's there's like an optimization fence for when it collapses the with statement and when it doesn't, and it can be really slow to do it with the with statement and having writable queries inside them because the optimizer doesn't really know what the side effects are going to be at that moment. Yes. So, any thoughts, questions? Time for lunch.
Lunch actually is
Yeah, I don't know.
a little while, so
That is.
I have to go to another meeting.
Thank you.
Thank you.
Well,